The hell? Oh. This is the first one. This is Fips 203, 204, 205. Anybody who knows me knows that this is my, and intimately familiar with this buddy. Actually, I won't do that. I'll close that for now. It's kind of gross. I have a feeling I'm going to want some code in a second. People in the chat, if you have questions, please give me questions. Otherwise, I'm more likely to be quieter. This computer's old. This is an incomplete implementation of Ml-Kem, but I'm literally in the guts of it, and I was just looking at it 2 seconds ago, so. So before we get into Module-Lattice, this press release. This is the actual update to the Federal Register with a little bit of context, so just skimming over this. Blah, 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 blah. Key establishment. It's not key exchange, it's not key agreement even. It is key establishment. And then signatures. Yes. Yes, they do. Yes. Yes. Derived from. I'm gonna get pedantic about Kyber versus Ml-Kem and dilithium versus MLDSA. If you have any problems with this shit, go test Dustin. My mic seems to record mono. Oh, let's see. Yeah, you're right. Let's see if I can fix that. Thank you, shopping. Actually, does that do anything? No. I wonder if this is being configured via macOS. If you have any tips for it's not ticked as mono, so I don't know what to do about it. Sorry. If anyone has any tips about making my mic via OBS not be mono. I don't know if I can duplicate it. Mono? Hey, I have to tick mono. That's not better. Hopefully that's less weird for the headphones. Let's see. I'll put this down in the back. Yay. I don't stream often, so And I bet you I didn't have the interface and thing in that I had before. Let's see. Oh, I think I got too loud for the sleepy puppy, and now he has to move. Okay. I wish I could like go like this and show you this extremely cute dog I have. Maybe I'll figure that out next time. Let's go. This poor computer. This MacBook is at least like 5 years old. I need to replace it. Wow, okay. Quantum computers, blah, 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 blah. Yes. Yeah, those are junk now. La, 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 la. Yeah, this fucking took almost 8 years. This has been a long time coming. I was telling a civilian about this today, and I don't think I quite communicated how long we've been waiting for these fucking little documents to drop. Yes, I was right. Okay. There were 80 plus submissions that were, and only 69 were accepted. Because I've been telling people 80 recently, and it's not 80. It's, sorry. Like, I saw other places that were like, there were 69. I'm like, I remember 80 plus. Some of them did not, qualify. So, let's see. Blah, blah, blah. Blah, blah, blah. Yeah, and then we went to 26. And this was everything. It was just like, it wasn't even give us chems, give us signatures, give us this, give us that. They were just like, give us a bunch of shit. And then eventually they turned it into, Life Under the Virus, I saw the validator people have some test vectors though. So you have to go somewhere else besides the Fips document packages. There's like another, I think they actually have like a repo on GitHub now. And I'll go try and find that in a minute. But I think they sent mail to the PQC forum list. Oh yeah, it was. But I'll try and go find that later because like the validators at NIST have said like we have updated some stuff and we're ready to like start validating implementations of these 3 algorithms. So I'll go look for that in a minute. La 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 la. It's been a fun couple of years. Like a lot of like breaking and building and breaking again and weakening and stuff like that. Yeah, so that was 2019. Oh, is that the internal functions? Are the test vectors in the Fips, or does that include the other validation thing? Oh god, I hate that. We just updated our draft for X-Wing with new test vectors for Ml-Kem specific, and so I have empathy for people who generate test vectors, but now they're going to go in some sort of whatever NIST has for errata. People don't read the errata, so that sucks. Most promising candidates. Second round. Yeah, and then the 7 final and 8 alternates. And that included one of my favorites, the Tord. Yes. Part of the reason why we don't hash in the fucking ciphertext in Ml-Kem anymore, which is, in my opinion, unfortunate. Gotcha. That's rough. Yeah, the ACVP, CAVP, whichever order it's supposed to be. That's annoying. That's really annoying. I wonder why they did that. Maybe because they're optional. I don't know. I have to go. I've honestly been holding off on going deep into these documents until right now so that it can be like fresh and novel and interesting and stuff. So, this is for you, stream. This is for you, chatter. Blah, blah, blah. Yeah. God, all this stuff happened during deep COVID. La, 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 la. Yeah. The only chem we have so far, and the 3 alternates that are still floating around are, and then we've got this. This is cool because they say somewhere else that, I mean, we could have guessed, but it wasn't confirmed, that Falcon is going to be Fips 206, and it will be FN DSA, but that's still scheduled to be later this year. So that'll be interesting to look at. And then Sphinx will be capable of protecting U.S. government information well into the foreseeable future, including after the advent of quantum computers by themselves. Just, especially the Ml-Kem stuff. CNSA 2.0, which is what the NSA says that national security systems, like top secret classified information protecting national security systems, will need to be Ml-Kem 1024 alone, not hybrid. And that's good enough for them. So that's it's a big, big, big endorsement for trusting Ml-Kem. Yep. Ml-Encapsulation derived from, not the same as Crystal's Kyber. It's gone through several notable changes since both the original and second and third version of the Crystal's Kyber submission. So if you want to be a post-quantum cryptography pedant to your friends, you need to go, are you talking about Kyber, Crystal's Kyber, or are you talking about Ml-Kem Fips 203? Because those are not the same thing. Because you are technically correct, which is the best kind of correct. Blah, 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 blah. Key establishment, shared secret between 2 parties. And yeah, I think I spoiler warning, they've hard-coded the shared secret to 256-bit. You can't do bigger or smaller or anything like that for all the parameter sets for Ml-Kem. Yeah, that's discrete log and that's RSA. Okay, and then, yeah. Dilithium and stateless hash-based signatures, aka Sphinx. I mean, it's not just about being like, you know, which thing you're going to talk about. They have different security properties. Like, not that one is like dangerous to use and the other one is like safe to use. It's just they are different in terms of the actual security properties they give you. And of course they are not interoperable, and so it actually matters in practice which thing you're actually using, because it gives you slightly different security guarantees, and it depends, like decisions that you're making about the rest of your crypto system, like your protocol or whatever you're doing, matter about which thing you're getting from Kyber and which thing you're getting from Ml-Kem to design the rest of it and to give some sort of like security proof of reduction or something like that. Or it makes you have to know those things to make other choices about the rest of your whatever else cryptography you're doing. In the future, Fips specifying digital signatures to Falcon, yes, is an alternative. Yep. And yeah. And we already have it's like XMSS and the other stateful hash-based signature schemes, which are just harder to use in practice than Sphinx, which is now stateless hash-based digital signatures. And I know that people are very, very confident in those. That's Fips 205 now. Published a notice in the Federal Register last year. And so we have the comments. That's cool. That's good for public transparency and whatnot. All right. So this was against Wait. I'm assuming this is from the comments on the initial public draft and not the previous versions of Kyber. Okay. And then for reference, this is the initial public draft. This is the thing that I've been fucking staring at and ingesting for a year. Like, it's basically a week, almost a week until exactly a year. So like I'm very familiar with this 50-page document, and now we have a new 56-page document with extra shit in it. So this is just sort of a review. Shake, sure. And then I think they improved this. So I haven't even looked at the dilithium or the Fips 204 MLDSA thing yet. I do hope that they have just a lot of consistency improvements between the final Ml-Kem and the final MLDSA, because they were like, the nice thing about the crystals stuff, because they were like, Ml-Kem and like crystals dilithium and crystals kyber are just like sisters from another mister. They're so similar. They came from the same family, the same authors, the same, you know, everything, the same paper writers, the same, like a whole bunch of stuff was just like so nice because they're very related. And then the two drafts from Fips for draft Ml-Kem and draft MLDSA looked like they came from like two completely different people, and it was just kind of rough because you were just like trying to, there's a lot of shared stuff between Ml-Kem and MLDSA, like under the hood, the math and like algorithms and stuff like that, that it was like annoying that the two specs were so like on the surface just different and stylistically different, all this sort of stuff. So hopefully they're gonna look better. And I'm just gonna get going because I don't have forever here. I want to change this. Cool. Making those better. Guidance. Additional guidance later. Yes. Okay. Yeah. Please. We definitely need those. There's existing documents that they have said in other areas how they're going to update them for things like KDF guidance and other things that we actually kind of really would like to have on the record from them if you want to make things Fips compatible. But I don't think they're up yet. Side channels. Outside of scope. I'm pretty sure all the algorithms are constant time. I'm pretty sure. But someone can probably check me on that. So other stuff like power leakage and whatever is, I think, out of scope for them. The description of stated characters removed from the document included a future revision. Interesting. Of SP 857. A generic block cipher, not specifically AES, is what was described. Okay. Wait, Fips on. Wait, what? Oh, that was all of them. Right, okay, for comments on Fips 203. Version of decaps has not been sufficiently evaluated. Just current generation step was not modified. Oh yeah, failed checks. Yeah, let's... Quick spoiler. Yeah. Yeah, that makes sense. Yep. They are variable in the sampling. And I think... I don't know if the algorithms are specific enough to cover the case of like these leaky divides. Yeah, architectures are very weird. Yep. Yeah, I looked quickly, and they include these like validation steps for keys that is nice to see that were just not there. And I remember we were debating a lot of like, okay, if we're not going to make these changes, if we're not going to be able to make significant changes to Ml-Kem to get like highly resistant binding properties, to get the output shared secret to tightly bind to the public key and the ciphertext, then like, you know, we have to do all this extra stuff. Yeah, it really should. Unless you're me and you're just trying to get everything else in your implementation to work, and you're just like, fuck it, I'm gonna have real simple math and, you know, modular reduction here just to get everything else working, and then with a big to-do warning, safety warning in my Rust code that says, to-do, replace with real with real modular reduction and Barrett reduction eventually, and I have not got to that yet, of course. And now I have to like rewrite half of my code because they removed some shit and they went from like bits to bytes and so on. So like, one should, and yet especially because like in the initial public draft of Ml-Kem, they're just sort of like implement field arithmetic, and for like, it's the modulus is only like 3,308 or something like that. It's like a very nice little small, it's easy to do like school book modular arithmetic in a non-stupid way, as opposed to like if you have like a 256-bit prime field blah 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 for elliptic curves, just you wait. You've got Fips 206 coming down the pike, and that's got your floating point for you. Yeah, so it'll be interesting to see now that this is finally landed. People have been implementing this for a bit now, and we've gotten some things like the, you know, leaky divide happening, and we think we fixed those, or at least we know how to address those. But it'll be interesting to see now that it is officially a Fips, is officially landed, and it's locked. Modulo fucking test vectors that need to be changed. They might, I don't know how they handle that. See other people just sort of naively try to implement it and see what interesting bugs come out of those kind of more naive implementations. It'll be interesting. So, all right, I'm going to get through this quickly. Yes, now we have validation checks. So when we were complaining about, oh, if you just do this as written, you don't get strong binding properties. And if you just do it like so, you basically get everything you want for free, and it makes it really easy to use. And then we don't. But also, like, the alternative, if they didn't change it, which it doesn't look like they did, is to validate your keys and make sure that they're well formed, and like check, like if you have an encapsulation key, check it, and you own the decapsulation key, like check that it generates correctly, or whatever. But there was no laid out validation in the initial public draft for Ml-Kem, and now there is. Although they have spoiler, they have like a line that's basically like, just because this validation check passes does not necessarily mean that the keys were generated correctly. And I think that's because of like sampling. Like you can validate the keys to make sure that everything is like correct in itself, but that doesn't mean you like sampled it correctly with the correct distribution or something like that. I think that might be difficult to have a detection check that's not too expensive, but we'll read more and see. Yeah. Cryptography floating point is like, I don't know if Pornin is still here, but Pornin is probably one of the few people that I trust to be able to do like get cryptography implemented over floating point arithmetic correct and secure and not full of side channels. And he basically has said it's really fucking hard, although he says it with an incredible like Quebecois accent, and he's much less vulgar than I am. It's fucking hard. I don't want to do it. I'm gonna look at Falcon when it comes out, or whatever, FNDSA Fips 206, but like, I don't know. We'll see. So now that we have validation, which is great, Yeah, the core algorithms are difficult to test because they're non-deterministic. They fixed that. Now they have all this stuff that's like deterministic, and then you just like wrap it with the wrapper that sources the randomness and just shoves it into the internal function that takes it as an argument, which is nice. Readability, yep. Bytes and bits, language, byte strings, exception of shake. Okay. Okay, I hope so. Yeah. Yep. This is very funny because, like, a lot of people who have been paying close attention have been like, who's ever going to use 512? Because, like, one, this is new and attacks only get better. So, like, if you want to be a little bit conservative for the long run, why would you even go with 512? Go with Ml-Kem 768. And then, like, a couple of weeks ago, I think, Meta put out a blog post being like, hey, we're starting to deploy hybrid TLS 1.3 internally, trying to move towards doing it for basically all of Meta, all of Facebook, Instagram, or whatever. And they said, we had trouble rolling out hybrid Ml-Kem 768. It was a little too big. And if we used Ml-Kem 512, it was fine, and it fit in our like our TCP windows and all this sort of, you know, I don't know if they had weird shenanigans or just sort of normal TCP shenanigans. But they were like, yeah, 512, it's useful. Like, we're deploying it. So it's, yeah, people want 512. People want 512 for a variety of reasons. And the people who are like, no, don't, if you don't have to deploy 512, go with 768. If you don't have any constraints in that regard, sure, you'll be good to go. Not too big, not overkill. Ml-Kem 768, pretty good. Whether the security of 512 will hold up, just because it's kind of like the bare minimum parameter set, it's kind of just me hand waving. Big shrug. We're not sure. I don't know, but it fits. It doesn't blow up your sizes and your frames and your packet sizes and stuff like that. So people need it. What about SHA-3 and TurboShake? Are they too big? Are they too slow? Are they not adopted? Like, what's fun is there's lots of SHA-3 in here. In Ml-Kem. Yes. Very, very, very second half 2024. Too many rounds. Yes. JP Elmanson did a good talk a couple of years ago at Real World Crypto arguing that we just have a little bit too much crypto. We have too many rounds of, you know, what your internal round function is and your hash function, or too many rounds for your block cipher. Just too much crypto for the security that you need in practice, which, good argument. For brand new stuff like this, I would not say that we're anywhere close to too much crypto for very novel stuff like this. Hopefully I'll be wrong and we'll be able to be like, we deployed all this 768 and it's too big and we don't need it, and the best known attacks in the world are way too expensive to leverage against 768. We can cut it down to 512 and have a nice margin and not worry. Great, awesome. We might be a little bit too got a thick armor out there for a little bit too much. We'll see. One nice thing though, Ml-Kem, I think the update for Meta also had some good stats that when they added Kyber 768 to X25519 for key exchange, they only got a 40% increase in cycle count in computation cost, not 100% or even 50%. So 768 computationally is still cheaper than doing computationally cost and then doing, according to Meta, amortized over a bunch of mostly TLS connections. Maybe there's other settings where it matters. It's cheaper. So that's pretty cool. Yeah, I'm excited about that. I'm glad that got in there. Whether the choice of SHA-3 and SAW, like, basically you'll wrap up your Ml-Kem and you have a nice blob, that'll be your Ml-Kem. You don't have to worry about your SHA-3, but yeah, we'll see if there's grumbles in practice, but whatever. Like, you might have a KDF for your real thing outside of Ml-Kem. If you, like, inside Ml-Kem, you've got SHA-3 as your KDF. Outside of it, do your HKDF, HMAC, whoosy what's it, blah, 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 SHA-2, all that nice construction. You can do cheap stuff outside of it and just worry about software or, like, intrinsics-based, instruction-based, whoosy what's it's inside your Ml-Kem implementation. All right, I'll go through this. Yeah, I'm waiting on this. Yes. Will be happening. Yep, we want it. We want, like, official on the record stuff about hybrid stuff. Exactly. Yes. Okay. I don't know if that's a new 800 series document. Any bets on second half? Oh, when in the second half? I mean, we are in the second half of 2024. I have no information to inform a speculation of when in 2024. I have no idea. I really have no idea. I vaguely have a feeling that because there is no public draft for Falcon yet, and there are no public drafts for any of these updated other documents. I don't know if they do that, but they have to do a public draft of Falcon. I don't know when that's gonna come out, if it's gonna come out. If I'm wrong about that, if there is a public draft for Falcon, let me know. But I'm pretty sure there is not. I would be annoyed if they lollygagged significantly on getting those other updated hybrid guidance, updated KDF guidance, updated SP 800, 56Cs, whatever. If they lollygagged on that, because, like, I got a question today, literally, about, like, how do I do it XYZ way? And I'm like, we think this is fine if you want to get this thing Fips certified, but we're not sure that is fine. So getting guidance will be nice. Yep, they fixed this. This was a little bug. I don't know if this is the transposing of the A matrix, but I will be rereading that now because I just implemented that and I was like, I think this is fine. I hope it's fine. But I literally have not, like, run my code yet. So it's probably broken as fuck. But, like, there's several things that are probably broken as fuck. Reintroduce a step in caps from third round. Hash the randomness was using this is before it's using in caps. Oh, yeah. Did not reintroduce. Yeah, I didn't expect them to. Yeah, that would have been... Yeah, they're basically, like, use the random generators that we told you to use. They're good ones. It's like... Yes, I wanted this. Yes. Yeah. Does not require... Yes, in CCA 2, or whatever, people will call it just in CCA for chems. It's in CA 2 for, like, public key encryption, period. Does not require the ciphertext, blah, 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 blah. Yeah, we know. It's not for that. No. There are known security benefits for different security properties than in CCA, but I don't think that we knew about them when public comments closed that this is discussing. I think it literally got published, the keeping up with the chem stuff and the binding properties for chems. I think it got published just a little too late to be included in this stuff. But it wasn't too late to be included, or like changes based on that to be included in Fips 203. Whatever. Like, yeah, the change to not include the ciphertext. Yeah, it's because one, you don't need it. Two, they're not really throwing shade. I talked to one person from this, and they basically were like, I tried to make the case for not necessarily including the ciphertext back into the internal KDF of Ml-Kem, but other changes like the key structure. Like, you can get better binding properties if you do certain things with the keys, so that they cannot be, they're resistant against a malicious adversary or whatever, to get the key binding properties. And they were just basically like, this was really hard, and usually I'm able to just like make the case and that they listen and we can include it. But I think it was just a lot of change too late, and it was hard. It's kind of new, and like it's blah 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 blah. So it's a shame. But now that we have the validation, explicit validation stuff in there, I have to go read it. But if we have that and people do it in practice, that's at least kind of like a stopgap. So maybe we don't have explicit mal binding in Ml-Kem as specified in Fips 203, but we're able to mitigate it. Yeah. So I don't think they're throwing shade. Yeah. A lot of too late. I don't know what to tell you. Like, people were somewhere along the line, people decided in CCA is the only thing we care about for chems, and only late did people who like had a history of looking at Diffie-Hellman, small subgroup attacks, invisible salamanders, or whatever that thing is, like these kind of like weird confusion properties that happen when integrating stuff into protocols. Start looking at this and just be like, oh, this is like, there's other stuff here that we care about besides just in CCA. And it did just come a little bit too late. So that's unfortunate. It would have just made things real nice and easy to just be like, yeah, you can just fucking, it would be so great if we can just say, yes, you can just like do an Ml-Kem and just spit out the shared secret, and you don't have to worry about also hashing the public key or including the ciphertext in your KDF. You don't have to fucking worry about any of it. You could just use the shared secret. It's fucking awesome. Isn't it so great that we can just do that? But we can't. So it would have been really nice. There are others. I have to go look at the spec of Frodo-Kem. Frodo-Kem, as written in its original papers, should give you mal binding for K to PK and K to CT. But when you actually specify it the way like the keys are going to be and the way the keys are formatted, when you give it to decamps and stuff like that, I think it's also a little bit squishy in the way that kind of Ml-Kem has and is squishy, and you can write a proof that says, oh, I can break, the adversary can win the malicious binding security game. Yeah. Yeah, it does suck that there's no Semver for Fips, and the other stuff is the work of the ITF. Tell me about it. Tell me about it, Paul. Semver for standards documents. That's a good idea. And if you're interested in more good ideas like this when it comes to standards documents and cryptography, the Community Cryptography Standards Project, C2SP, which you can find on GitHub, does exactly this. They have documents, and they are versioned, and they have Semver, and it's exactly the way that kind of modern software people who take care of documents and things that are versioned, that have like an API boundary and compatibility issues and all this sort of stuff, they do it like that. It's a very good idea. I am not. It's good stuff. All right, I'm going to move through this. Yes, it's not going to be hashed in. We are all sad. I mean, yeah, that's not the thing that I'm saddest about. It would be nice if we just didn't have to worry about that. But I understand their arguments why. Yes, storing a small seed in place of larger keys, using the store. Yes, because that would give us those nice binding properties. So this is the thing. Keys can be regenerated from saved seed values, but that is not required. It's not like how you do keys, and therefore, like, who's gonna do it? The people who know and have an informed opinion about, like, ooh, if we do keys as seeds, we get this nice stuff. We get, like, in practice, we get these nice Ml-Kem stuff. But then, like, if you're just fucking reading the thing, it's just like, here's the algorithm for generating keys. Here's the algorithm for encapsulating with them. Here's the algorithm for decapsulating them. And, like, it's like, you have to already be kind of, like, clued in to the value of that thing to go and be like, notice it, and not just like, if you're just like, this is how you do, I'm like, we'll see how opinionated implementations, like in your boring SSL and, you know, other places, will do it, because that will help, like, inform how people do Ml-Kem in practice. And we'll also see, like, we'll see, because I know Wolf SSL, Wolf Crypt has already gotten some stuff validated recently. I don't know if it's for hybrid TLS 1.3, probably not, because it wouldn't pass anyway. I would be very curious to see what the first sets of Fips validated implementations do. If they support this and they kind of lead the way, that's great. That gives you better binding properties in practice. If they are, like, very, like, your decaps key is just like a bunch of exploded crap, the way that it's currently written as, like, you know, an encoding of a key, and, like, the algorithm that says Ml-Kem decaps, like, when you look at the fucking thing, we'll see. A few commenters raised issue on the requirement for decaps function to implicitly reject on a protocol failure. Yeah, that's how it's designed. It's implicit rejection. Almost all of the chems that made it past out of the first round of submission turned into implicit rejection chems. Okay, whatever. I don't know. It's an interesting debate to have with people who have opinions about this, about the value of implicit rejection. It was supposed to be, what you call it? Implicit rejection is supposed to give you a long, pretty random value no matter what. So no matter if something fucked up on the back end, you won't come to agreement. But if you just shove that into AES-GCM, which you should not do, by the way, you should just, instead of, like, taking an Ml-Kem and just shoving the shared secret out of it into AES-GCM, you should use HPKE. And if you have questions about how to use Ml-Kem with HPKE, I have documents in the IATF about how to do that, and so I can help you with that. HPKE is the modern way to do hybrid encryption, where you use the public key encryption like Ml-Kem or, you know, RSA to encrypt a shared secret, and then you use the shared secret to encrypt a bunch of stuff. Like, you know, there's lots of protocol nastiness that we've learned the hard way that's addressed and done nicely by HPKE that is not covered if you just shove an Ml-Kem secret into AES-GCM. What the fuck? Oh, and if you do that, if you do kind of the naive thing, it'll always give you something. If it's not going to shove out 0, or it's not going to shove out a null byte that you're just supposed to know, means, like, this was explicit rejection. Because if you don't know, and you're sort of like, yeah, and you end up using that as your AES-GCM key, like, oh no, like, that, like, it's a very kind of, like, very overt failure mode that's like, check the thing, and if you don't check the thing, like, it's a null, it's an extremely predictable null AES key, or, you know, encryption key or whatever. So I understand why implicit rejection was adopted by basically all these chem designs, but there are other people who think that, like, we could have done an iteration on that. Like literally you can output your shared secret, which is an implicit rejection chem shared secret, and a flag. And like the flag is like a Boolean. It's like, you know, 0 or 1 that tells you like, and that's going to fucking fuck up the security game about the distinguishability, about the fucking implicit rejection key in the first place. So I don't fucking know. The other people who have more opinionated opinions about that can make that argument better than I. But but this is what we have now. And basically everything that is a chem and almost all the key establishment solutions that we have that are post-quantum just turns into a chem shape. And they almost all are coalescing around implicit rejection. So like that's a water cooler or over beers argument to have, you know, another time. Can't this all be solved by an IETF portable format specification? It could be, or it could have been solved by the Fips specification, because people will implement Fips who don't give a shit about the IETF. So maybe, but like, it's also, yeah. Like, if your Encaps argument is blow up the thing and like parse the pieces that may not be bound to each other, like an attacker could modify your decaps key. That's the malicious adversary for malicious bind, and just be like, no, I'm going to replace the hash of the public key with my like an old hash of a public key of another key, so that it will output the correct thing because of all the way that the, you know, FO transform works under the hood, and break the security game and break the malicious binding properties of the shared secret to a public key or the shared secret to a ciphertext. Like, once you start blowing up the thing out from a single seed, and once you, like, the thing starts to crumble, at least away from the malicious, the highest level of binding security, into something that's closer to leak. Which, for the record, it's hard to make good arguments so far. I've found it hard to be like, if you had malicious security, binding security for that chem in this case, you would be protected against this thing versus leak bind. Leak bind KAPK and leak bind KCT may be sufficient for general cases. It's kind of early to literally say that definitively, but we'll see. We'll see. Implicit rejection means you don't have to check return values. Yep, exactly. There's also weird proof things when I'm a fake cryptographer. Proving the NCCA security of the FO transform period, there's several flavors of it. There's explicit and implicit rejection. They're all flavors of the FO transform. Is apparently a difficult proof period, because I was like, oh, I have done such and such a proof for Ml-Kem or Kyber or whatever it was. And then I said, okay, now my next step is I'm going to prove in CCA of the FO transform of Ml-Kem. And like every other cryptographer who's like looked at this has been like, oh, wow. Oh, that's, you know, have fun with that. And I'm like, oh, never mind. So I think implicit rejection makes the proof nicer and easier and more elegant and simpler. But the proof itself for FO transform is just like a lot. And like other better people who are better at proofs than I am do that. I haven't done that. Hello, David. Relying on the IETF to solve this is not always a good or fast idea. I very much agree. NIST is slower, yes. Generally, yes, but also, like, we basically already asked them. One, we asked them while they were doing this, and they were just sort of like, too late, but also we weren't convinced enough to make it happen. It wasn't too late. Now it's too late. Like, it's done. It was maybe too late a month ago when like people were like, oh yeah, the thing's done and now it's with the lawyers and it's gone up the chain to the Secretary of Commerce. It sucks. Maybe we'll do something in IETF that some people may use, but there's going to be a, you know, Cambrian explosion of like, okay, well there's Fips 203 Ml-Kem and there's IETF compatible Ml-Kem and so we'll see. We'll see how much it matters. I don't know. We'll see. Increase the seed size. I think, yeah, 32 bytes sufficient. Multi-target attacks. Okay. Failure rates. I don't even remember what this was. I'm gonna skip all the way into Fips 203 now because I am very, very informed about all of this, and I'm less informed about everything else. So this is the official Fips 203. Some problems between Fips 204 and some of the IETF signature stuff we'll have to work out. Yeah, I'm not surprised because they differ. There's enough difference between Fips 203 initial public draft, which is this one, and the final Fips 203 that I have to go change a bunch of code. Anyone uses non-IETF cha-cha poly? I don't know. Probably. I have a feeling that libsodium may use the non-IETF cha-cha poly because libsodium's an old project at this point. And I don't know when the IETF cha-cha poly was written down. That's a good thing to investigate. If I was going to guess, probably that. And lots of people use libsodium still. All right, so this is Fips 203 draft, and this is the real Fips 203. I'm just gonna do it the original order. Yeah, they do X also. And look at that. It's a real boy standard with herself, Secretary Raimondo's name on it. That's pretty cool. Series, go talk to someone else, like that guy. Although they said elsewhere, talk to Dustin. Poor Dustin. All right, set of algorithms. They also changed the font face. They changed a bunch of stuff. Yeah, modeling others problem. Believed to be secure. Well, I wish they would say a sufficiently large or you know, whatever. Yeah, the fonts are different. Like, sure, whatever. I don't know. Hero boy and girls. Yes, yes. Oh, I know, Paul. It's a real boy RC the way that you know, Pinocchio became. I'm a real boy. Yes. All right, let's go. There's a bunch of blah up front. Skip. Used or operated by federal agencies or by a contractor and agency, blah. Yeah. This will be applied to national security system via CNSA 2.0, which is elsewhere. And it's also kind of like not as like hardcore lockdown as these Fips things. It's kind of like a smushy kind of thing. Modern computer sans, LaTeX. Well, I don't know if I guarantee you that this thing was generated by LaTeX, but I would be very surprised if it was not. If there's some other thingy that you can use that's not secretly LaTeX under the hood, that's cool. Software, firmware, hardware, or any combo thereof. Conforming implementation may replace the given set of steps with any mathematically equivalent set of steps. This is like a non-trivially load-bearing phrase. Like, we have all been like, sort of been like, can we do like having a decaps key be a like 32 by root seed that you put through like turbo shake and generate like the two, now it's going to be like 2 seeds, sub seeds. And then from that you generate like the K, PKE, decryption key and like all the pieces, and then the row and like the random and like all the pieces that you need. If we like slide that in, does that count as you know, a different procedure that produces the correct output for every input permitted with a mathematically equivalent set of steps? And like, we don't know, and the answer is going to be, if you can get it Fips certified, it will be. Real PDF viewers. My browsers are my PDF viewers. It's yeah. All the ones that aren't browsers crash on me. Thanks, iPad. NIST uses Word. I'm sorry. Yeah, does that count? Yes. Ask your validator. Yes, developing a program. Okay, and then this is not on github.com, but I'll go look anywhere. Okay, this is a bit extra. Patents. 2 patent license agreements. Blah, 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 blah. Freely available practice by an Ml-Kem is published by NIST. Ooh, that's gonna be fun. I wonder if that will affect anyone trying to do, you know, things in the IATF. They're like, here's a, I don't know. That'd be curious. Let's see. Implementation schedule effective immediately. Yeah. Qualifications. Including randomness used by the 2 parties. Decaps key shared secret key. Yes. Shall. This is funny because this is extremely like IETF vibes, but like this shall, which is lowercase but bold, and it's a shall, is like the equivalent of an IETF uppercase must. As opposed to IATF uppercase should, which is weaker. General performance design. Ensure. Yeah, the invitation is secure. Yep. Any module that implements key establishment capabilities designed and built in a secure manner. Sure. Formally every 5 years. That'll be fun. All right, set your calendar for about 5 years from now, and we'll just like put this one and any updates side by side and see if like anything terrible pops out. Yeah, exactly, Paul. Waivers, copies, blah, 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 blah. Yeah, this is how you're supposed to cite it. Sure, whatever. Okay. So this was the first, whoops, sorry. Where'd it go? Is it here? Yes, it's here. So 21 algorithms in the final compared to, do they have it? Do I have it? Yeah, 17 in the original, in the initial public draft. And I think, yeah, I think it's just mostly these, the internal variants, and then maybe one more thing. They did remove this guy. Where did it go? It was algorithm 8. Oh, I think they had like bit rev 7 or whatever it was, and they didn't list it. It was just sort of like a subset of NTT or something like that. Yeah. But all right. Yep. Context. Yep, we've got a lot of context. Blue. Fresh random value. Yeah, equivalent process. Sure. Fresh random value output for a random bit generator has not been previously used. All right, I'm gonna try and blow through this. Yeah, shall, requirement, should, strong recommendation, but not requirement. So at least we align with IATF on this. So, stupid, important, but you know, itty bitty little, you know, building block things. IPR on the IATF, no IPR statements on Fips 203, add IPR. Okay. Anyway, that's just my stylistic opinion of like, that's a function. Like, that's a function very similar to all these other algorithms. Although, like, R mod M, like, you can have piles and piles and piles of code implementing R mod M. So, I don't know, whatever. Yeah, transpose. This is another thing. I don't think they, like, there's a ton of stuff in here that's like literally just like linear algebra, but some of the stuff is just, you know, really, really laid out, like bits to bytes and bytes to bits and stuff like that. And I guess for endianness that matters, but there's other stuff that's like kind of this pure math stuff that is just glossed over, and I'm pretty sure they're keeping it that in here. That's just sort of like, just transpose this matrix, you know, just, you know, do a matrix multiply. And I'm like, there is a lot of literature about how to do an efficient, secure matrix multiply. So like, you could just like write it down, and they're just like, nah, it's fine, figure it out. And like, I understand that like you can't put literally fucking everything into a document like this, but like, maybe that's where you get the kind of like equivalent mathematical computation stuff in there. Like you can just like hand wave that away and just be like, yeah, we're not going to explicitly write this down because you have a lot of options for that. And it's like, okay, fine, but you could take a lot of like question marks and hows and you know, like which way should I do this? You could make it really easy for people, and you could just make like, here is a implementation of transposition, matrix multiply, whatever. Because they do the NTT transform. The NTT transform is extremely important, but it's also kind of like very similar. There's a lot of wishy-washiness, sloppiness regarding why when they are using matrices or elements of the matrix in the draft, at least. Yeah, I agree. So, oh well, whatever. I am not an author at Fips, but when I have authored similar documents, like we put a lot of stuff in there about like how to do stuff like this, but I don't know, whatever. Like polynomial stuff. Like when we were writing Frost, like just a lot of language about literally how to do simple polynomial operations. 2 minutes ago, Nis said they'll have updates to 203 for errors. That's funny. Let's see. I'm going. Are we over here? We're over here. Thanks, Paul. That's funny. Come on. Blah, 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 blah. Oh, they already have something that was already certified? Oh, cool. Ooh, I'm gonna look at those. I'm gonna look at those and see, like, spec should be executable and specified in formal lang. I very much want that to be true. Might be incorrect. Interesting. I very much want that to be true. There's work on that. If you've seen the hack spec stuff, and now hack spec has turned into just basically like a compiler that will take almost all of Rust, of like standard Rust, and compile it to F-star, EasyCrypt, Coq, whatever. And so you can like write your spec, an executable spec, an interoperable executable spec in Rust, and then you can translate it and do like all these formal guarantees and proofs and stuff about it. It's like a formal language, which is, I think, probably our best bet, because if you write your specification in a formal language, you're gonna have to translate it anyway. You're gonna have to because humans can't read it. A lot of people can't use F-star, Coq, Cryptol, whatever. A lot of them are like, I like Python. Can you write me some Python? And then humans are the hard part in all of this shit. Like when you try to have the humans do math and formal, you know, correctness and formal specification and stuff like that, it's not the formal specification, it's the fact that humans also have to like use it in other areas, and there's translation involved, and the humans mess everything up. These are cool. I'll look at these later. Adam Langley. I'm guessing he helped write some of the stuff. Oh yeah, Boz is already looking. La la la. Yeah, yeah. I forget who was saying like they're not up to date. One, they're incorrect, and two, they don't implement some of the new stuff. Interesting. Yeah. Internal functions. Sure. Yep. I agree, Marku. Yeah. Oh yeah, hash, pre-hash. Ugh. I forget. I think they said they weren't doing pre-hashing. I'll probably look at MLDSA. Not today. I'll have to drop in like 20 minutes anyway, but I'll come back. I'll do MLDSA, and I haven't even looked at SLHDSA at all. Force those functions to greater prominence than is wise. Not always cut in the sensible place for exposure. I mean, that's actually really interesting because like in the spec they explicitly say like these are not supposed to be public functions. These are supposed to be internal functions. The only like public interface functions are supposed to be keygen, decaps, endcaps. So yeah, it's kind of forcing your implementation, your module into a kind of funky state. Pre-hashing covered a new MLDSA. Is it covered as like you can do that over here, or do they like specify like here's how you do, like here's the pre-hash variant, or here's a pre-hash parameter set of MLDSA? Because like for example in ed 25519 there's like here's how you do it with pre-hashing, and here's how you do it. Like it's like there's like a plethora of cipher suites of parameter sets of how to do EdDSA because it explicitly supports pre-hashing. So I'll go look at that later, so you don't have to answer if you don't want to, if you don't know. Blah, blah, blah. Specify domain separation constants to prepend and allowed algorithms for pre-hashing. That I like. That's the way I think one should do it, and basically say like instead of they are parameterizing it, but they're not like they're not giving it the same kind of prominence as like these are the other parameters. This is like MLDSA is whether you're pre-hashing it or not pre-hashing it or whatever, like MLDSA is MLDSA. And if you are pre-hashing, like that's sort of outside the boundary of MLDSA, as it were. It's all very kind of fuzzy, and like where does this even fucking matter, and kind of like where you think the boundary is. But I like the way they did that instead of what ed 25519 did, I don't know, years and years ago. Same mismatch as the server code. Oof. This doesn't diverge from specification. Doesn't cause tremendous interoperability problems with applications. Don't attempt to store private keys as seeds. But we want that to be an option. So yeah, bugs happen, but perhaps rushing to obtain certificates before there's many eyeballs on the golden reference is not wise. We put in a fix that should go out either later today or tomorrow. Another user on the forum pointed out similar issue for Ml-Kem keygen under PK keygen. Oh, in those cases, matrix dimensions are added to the seed and then hashed to form the key material. Yes. This is different than the draft Fips, but covered in this. Okay. Was it? Was this? Was it? That's interesting. Oh, sorry. Dimensions. This is the rank. This is K, right? And hash to form the key material. So that's okay. I'm closing. No, I'll do that later. Well, this is the old one. Okay. I can't just search for K. Let's see. Okay. Shell. Oh yeah, a modulus is 3329. Okay. Okay. Blah blah blah. Right. Okay. There was some input validation. Type check. Okay. Type check and modulus check. That's not a lot. This is the draft. Initial public draft. Incaps, decaps. Seed. Yes, to the seed, not to... Alright. Nothing there. Okay, I'm not 100% sure where that was in the initial draft, so I'm not finding it. Interesting. We got bugs, but we found them. Yay! Anything I missed? PQC. Oh, that was weeks ago? Okay. Alright, pseudocode. Yeah. Data types. Pseudocode is agnostic to how mod-M is represented in actual implementations or how modular reduction is computed. I know that this is like a modulus of like 3359 or whatever it is, 29. But I don't love that. I kind of wish they were a little bit more, like, recommend-y. Arithmetic, yep. Yeah, that's right, algebraic objects. I don't think they've changed this much. F hat. Let me tell you, I've become very familiar with the little Unicode thingy here that lets you literally do character and then paste immediately this little thingy after it to give you F hat and A hat and G hat and all that sort of stuff. Unicode's amazing. Yeah. NTT. Oh, NTT. Okay. Yes. Scalar multiplication. This is nice. I don't think they had this much fleshed out in the first draft. Never thought I'd hear. Unicode is amazing. Unicode's great. Just have like the one true encoding, which is UTF-8, and then you can, you know, turn it into bytes, and then it's a pinata of bugs. Yeah, well, I believe you. I like to make pretty characters with it. Arrays. Arrays, but not vectors. An array might be a polynomial ring element. It might be some random bytes. It might be a vector of polynomial ring elements. It might be a matrix comprised of vectors, comprised of polynomial ring elements. In this thing, they're just all... I want types. In my code, and where I get, you know, strong typing for free, I have a lot of types. Lots of types. All these different arrays are distinguishable and non-confusable at compile time in my code. But in this stuff, it's just all arrays. It's all arrays. And I understand why, but I'm just like... Or a matrix of one column. Yeah, it's fine. I understand why. Not everyone gets strong typing for free, but they should just, maybe they should just use a good language and not C. Yeah. Multiply my NTTs. Did that. I don't think this has changed much. Like, they literally use the word transpose 3 times in this final standard. And they just sort of do, there's like a very load-bearing, where is it? It's down here somewhere. They just have a little annotation floating around. A little T. Yeah, here we go. And they're just like, just make sure. It's going to break the test vectors if you do a shitty implementation and you miss that. If you don't use the transpose of the, you know, NTT domain matrix A to do this, you know, dot product or whatever, you won't pass the test vectors. But I wouldn't be surprised if I saw like a blog post or, you know, a bug in the future where someone's like, did you know that this requires like a whole like linear algebra operation to make sure you're doing the right thing? Because it's just kind of just, yeah, I don't understand why it's 2024. Because unfortunately you have to write a standard, you have to write a specification for everyone for 20 years, for the next 20 years, and we've got like 40, 50 years of like kind of tech debt that we also have to be able to like make it sort of work with, like C and C++, and maybe, I don't know, COBOL or fucking, I don't know. So, who knows? All right. I'm going to skip ahead. All of this looks similar. I've written the whole REST library to do transposes and quite complex to do efficiently. Yep. Not surprised. I am surprised that there's a lot of like linear algebra that's just sort of like figured out, just you can do whatever in this thing. Like if me, I'd be like, here is our way to do it. Here is basically every algorithm. Like I've done stuff that highly rely on modular arithmetic and then was just like, you need a thing that does this. Like go get your elliptic curve library, go get your hash function. But the stuff that you're implementing in here, like the matrix vector and the like polynomial ring elements representation is all like, when we were doing polynomials for our stuff, we're like, here's how you do it. Like it's all mod whatever, but here's the algorithm of how to do it. So I don't know. I guess people were like, if they put out a thing and it was floating around for a year and people did not say, please include, I'll go back at the comments. I don't think people said, please include an algorithm to do transposition. Please include matrix multiply. Please, like, I have a feeling that if there was like a wave of public comments that said, please include the linear algebra, like a linear algebra implementation of these common things, maybe they would have done it, but they didn't. So I don't know, whatever. Here we go. This is the same. This is the scheme. And yes, the assumption is that module learning with errors is hard in this instantiation by Oded Rugev. I think I met him once. These include a copy of Hacker's Delay and, of course, a computational algebraic number theory with the Fips standards. Yes, with the standard that says read these first. Yes! I would love that. They can afford it. Noisy linear equations, secret variables. Test is to recover X. Noise in the equations such as standard algorithms, Gaussian elimination are intractable. Yes. Yeah, that's basically a trapdoor. Difference is in M, LWE, Z sub Q, N is replaced by a certain module, R sub Q K, which is constructed taking the K-fold Cartesian product of a certain polynomial ring RQ. And then you transform it into TQ because it's faster, and then you go back. The secret LWE is an element X of the module RQ, bleh, blah, blah, blah. The ring RQ is discussed in detail. Yes. PKE, which I'm pretty sure one of my co-authors wrote a proof of the collision resistance of the PKE underneath MWE, and it's very lovely to be able to build stuff with that. PKE is converted into Key-Encapsulation mechanism using FO transform. Let's see. Do certain properties have no transform ability campers. Significantly more general attack model than the PKE. Yes, yes. Significantly satisfy in CCA2 security. I like how they're like so-called in CCA2 security, because in CCA2 is technically like about PKE, and then people have been like, well, when you're talking about a chem, there's only really in CCA. Whatever. Let's see. Yes, PK first. Transformation PK to Ml-Kem was crucial. NTT. So nice. With linear polynomials. Yep. I still don't understand why that works. Like, I haven't even tried to understand, like, why it's fine. But it's just sort of like, oh, that's neat. I believe you. Provable crypto was a mistake. I feel like we had a lot of mistakes way before we had the provable crypto that we deployed in practice. It was just like, it's like a base foundation. As long as we have like something, we have plenty of ways to fuck it up with the implementation and deploy it in practice. And so, as long as we have something, just a foundation. Hi, I'm streaming. Okay. Formally. Oh, decaps rates. Yep. Yeah, I left the door open and they just wander in. Professor so-and-so. Terminology requirements. Yes. Okay, PK is only a component. One might think, well, yes, obviously. Why is this like a top level bullet point? Because people have already been asking, hey, what if I use just KPKE for a certain little thingy in TLS, because all I need is yada yada yada, and if we've already got Ml-Kem over here, I'll just like go into the guts and use this component for this other thing over here. And it's like, nope. No one has analyzed it for that. Everyone has like, yeah, exactly. Like, no, just NO. It is internal, it is private, it is only in CPA, it is only chosen plain text attack secure, like at all. It's like, now it's been proven to have like, you know, collision resistance, something, but that's not CCA. Like, it's just NO. If anyone says, can I just tell them NO, the spec says no. Figure it out some other way. Use pure Ml-Kem. Just use it. Just use it straight up. And if they say it's too expensive, just be like, show me how it's too expensive. It's cheaper than X25519. Hey, if you want some fun, if you want post-quantum fun, let's go ski sign. There's loads of fun in there. And that's me being like, woo, let's go have some misogyny's fun. No, that singed, you know, smoking husk of SIDH and psych. Don't pay no attention to that. Ski sign. Like, let's go. Yeah. Oh, we live to see. I don't know if Blankenbacher is like really paid attention to any of this Ml-Kem stuff or any of these chems. Yeah, that'll be fun. I don't know if he'll find anything, but I'm curious. I don't know. Okay, only a component. Yes, shall not be used as a standalone cryptographic scheme. Only as subroutines. Yes. Controlled access to these internal functions. Yes, please. Interfaces for these functions should... Oh, no. Oh, no. I thought that would be a shall not. Remember, shall is like IATF must. And should is like IATF should, which is a strong recommendation, but not a requirement. He's too rich from padding his bank account. Heh. Oh, God. Okay, like... I wonder if their updates will address that at all. It probably won't, but like... Sampling of random values required for keygen, specified keygen encapsulation shall be performed with the cryptographic module. Okay, fine. That's the most important part. Fucking fine. Whatever. Equivalent implementations. Yeah. Specified algorithm may be replaced with a different procedure that produces the correct output for every input, where input includes specified output input as well as all parameter values and all randomness. Oh, God. Is that going to, like, imply they cannot make this a must not because it's about implementations? Isn't that their whole deal? I don't quite understand, Paul. If you can help me, I would love to understand better. Approve usage of the shared secret key are always 256-bit values under appropriate conditions, and that these values match can be used directly as a shared secret symmetric cryptography. Further key derivation is needed. Final symmetric keys shall be derived from this 256 shared secret in an approved manner. Yes. Which are the things that we would like more information about, please, especially for hybrids? Their whole deal is cryptographic module verification program. They can only test what something does, not what it does not. Okay. Oh, okay. I understand that. They can say must or shall. They like can't say shall not. That's just not how they do it. I get you. Okay. That makes sense. Right? Okay. All right. As discussed in Ml-Kem was an NCCA2 secure chem. However, a combined chem that includes Ml-Kem as a component might not meet NCCA2 security. Implementers should assess the security of any procedure and should the key derivation methods of SP856C are applied to Ml-Kem in combination with another key establishment procedure. More guidance regarding chems is given. Combined chems is given in this one? Fourth. Yep. Okay. Oh no, I lost my place. This is one of the things I hate about this thing. No, is that it? Yes. Is it? Yes. Nailed it. Looking out for you. Yes, randomness, input checking. Require input checking. Shall ensure they're only executed on inputs that have been checked. That will save a bunch of asses. FF for the win. FF? Finite field? Another FF? Okay, I'm gonna have to wrap this up. Structure of intermediate values. LOL. 2 exceptions to this rule. Yes, this is what was asked for. That, like, Firefox. Yes, the Firefox PDF viewer is S tier or whatever the... I'm old. Like, whenever I say language that's not from my cohort, I feel like I'm a huge poser. But No, I literally will go and be like, I know that there is like a hyperlink at like here. Like there is a hyperlink here. This PDF viewer will not show it to me. And I will open it in fucking Firefox and I will just to open the same fucking PDF, get the hyperlink and put it in whatever like thing I need to link into the subsection of the PDF. It's great. It is also memory safe. Hell yeah. Yeah, exactly, David. Well, you're younger than me, so you're allowed to talk like that. It's not cringe. The seed, D and Z, can be stored for later expansion. Yep. If this seed was just the root seed of both D and Z, like through like an expander, through XOF or whatever, or TurboShake, we can you do Ml-Kem in this very secure binding properties way, or at least it would be allowed and it would be Fips compatible. But it's just a little, just. So I'm curious how it's gonna shake out. Decapsulation key to sensitive data shall be treated with the same safeguards as the encapsulation key. Yep. The matrix A hat can be stored, so not be recomputed for later operations. Same matrix A is also generated. Blah, 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 blah. Matrix A has data that can be easily computed from the public encapsulation key and thus does not require any special protections. This is interesting because like a lot of people are like, why are we doing this all the time? Because it's a lot of computation to regen or do it once and haul it around when it's public data. It's basically like a public, like you can see the public, like NIST could have be like, here's a seed, this generates a hat, this is the matrix for all these different parameter sets of Ml-Kem. And I think a lot of people would have trusted it, but they are regenerating it fresh every time you do a keygen. It's interesting. Like it's something that's like is easier to do trust-wise. Like it's cheap enough and just sort of like, yeah, sure. Like we can just generate a fresh new matrix with this distribution to sample the randomness and blah, 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 blah. And it's cheap enough and we trust it enough and we understand it enough that we can just do that. And we like have one thing of trust that we don't, or like kind of, that we don't have to worry about. Unlike say an elliptic curve group or a generator for an elliptic curve group. Like you have to make sure that you pick that nicely because we know that there are ways that that can go wrong. But it's expensive and you don't have to do it. You could have just picked it and it would have saved stuff for people. So there's some people who are still kind of grumpy about that, but like, I don't know, like, sure, whatever. There's a shall not refloating point, which is implementation but justified given without such a floating point. Yeah, I agree. Interesting. I should talk to more NIST people. I'm curious about that sort of thing. Maybe, I don't know, maybe one of them will be at crypto. Maybe I'll run into someone and just be like, do you know this really nitty detail? Oh, here's the floating point. Shall not. Okay. In all pseudocode in the standard, which I have to, all right, I gotta wrap up. Division is performed. Y may not divide as blah, blah, blah. All these performed without floating point arithmetic. Ordinary integer division computes all these things for non-negative integers. Blah, blah, blah. Okay. I'm going to stop there and try to come back in maybe 2 hours if anyone, and I'll tweet and post and stuff like that. And I'll come back to Fips 203 because like, this is my number one Fips baby at the moment. Matrix 3, yeah. Ml-Kem, and then if you didn't find one that you liked, Ml-Kem rocks +1, Ml-Kem rocks concat 2, Ml-Kem rocks concat 3. Hi Strad, sorry, I'll come back. You can watch the recording and I'll start again. Shall not use floating point is testable. Okay. Is it? All right, anyway. Thanks for watching, I'll come back. Cheers, happy Fips.